Hello everyone and welcome. Welcome to Module 4 in classification. So jumping straight in, this module deals with rule-based classifiers. So what is it? And the basic idea is it is, as the name implies, the use of rules to classify things. And those rules, more importantly, are learned. They're not something that humans write. They're something that are determined using some algorithms to essentially determine it, how things should be split based upon some criteria. Once those rules are done, the important thing is people can understand them to some extent and can give them a bit of a evaluation to see if they seem representative and logical and make sense. Many things in this space, especially when you deal with things that are like connectionist in nature, so deep neural networks and so on, it's very hard to say why something is. It's hard to explain it, and that explainability is very important in a lot of places and a lot of applications. So being able to say why something is what it is very important, and that's one of the cool things and important things that rule-based classifiers bring to the table. And you could write these rules by hand, and people have written rules by hand, but more interesting and oftentimes more applicable is the ability to learn them, just as I mentioned. So they're inferred or learned by taking a look at labeled data. So you essentially do supervised learning against a set of rules and determine what is the appropriate set of rules. So in Module 4, you're basically developing analytic models using rule-based classifier techniques, kind of like what we just said. If everything goes to plan, by the end of this, you should be able to explain the concept of rule-based classifiers to someone else, and also be able to develop a classification model using a rule-based algorithm. Then lastly, as with most of these sort of models and so on, you need to be able to evaluate how well they did. So you need some mechanism of performance evaluation of a model. A very important and very common sort of thing to do. It's not just about making it, but it is about being able to determine if it was successful. So jumping into the deliverable 4. So what is it, right? And it's not surprising. You're develop an analytics model using a rule-based classifier. So basically, imagine that you work in a greenhouse, and your job is to classify plants. You have data that deals with the flowers it grows, including several of the species of irises. And this is actually a very old problem. You need to be able to tell from the flower what species a particular iris is. And this helps you be able to do pricing and so on. Bit contrived, but still very applicable. So your instruction is to use a rule-based classifier to achieve the desired result. The data set is comprised of 150 rows and the following attributes. You have the sepal length, the sepal width, petal length, and petal width. The class is comprised of basically Iris setosa, Iris veriscolor, and Iris virginica, I guess it is. Using, you can tell I'm not a biology major, using the matplotlib, sklearn, and orange libraries, perform the following steps. So basically you're going to load this data, and you can load it either using the orange data table load sort of approach, or you could also download it. This is a very common data set. Iris is actually distributed with Python and R, certainly R. It's been around forever. You need to perform some preliminary analysis using the first 10 lines of data. Construct the set of unordered rules by creating the learner object, CN2 ordered learner method. Use the data and the learner object to create a classifier. So you basically create a learner, you take that learner to create a classifier, you take the classifier to predict the class of all data instances, print the rules of the classifier's rule list, and then print the accuracy and the area under the ROC curve, UAC, using the following orange.evaluation cross-validation method. If memory serves, there's that may be challenging, but we'll get to that in a little bit. The last little bit, not the entire assignment. So what you need to submit is an executive summary that contains a description of the algorithm used to perform the computation, the results of the data exploration, and a table containing the performance metrics along with a detailed explanation of how the metrics affect the results. And then also, obviously, your Python code. So to take a look at the data, this is roughly what it looks like, the first bit of it anyway. And you can see there it is labeled. The first is the measurements of the various things we just talked about, and then the second column is the label or the category it belongs to. And this has been around for quite some time. I'm looking for the year. It's been around. So I've looked at this before, so I thought, well, I probably should go and actually know what these things are, the difference between a sepal and a petal. Again, not a biology major. So the little pictures there are intended to kind of help denote what those things are and how the flowers are of different classes and of different shapes. Interesting. I'm not the kind of person that could basically classify flowers. But anyway, there are basically three classes. That's the three that we just talked about. And you got 50 instances of each class, and they refer to a particular type of iris. And an iris, I believe, is an orchid. So one class is literally linearly separable from the other two. The latter are not linearly separatable. So that basically means that one of them you can't separate from with a straight line, essentially. The other two, it's a little more interesting than that. So you do have those four values that we talked about, the length of the sepals and the widths, and then also the lengths of the petals and their corresponding widths, and then the class of each of the particular flowers. So we'll go ahead and show the resources where you can go out and learn more about these. I think this is where it first came from. I'm actually kind of curious to see if it'll let me. I'm sure it's going to let me. Here we go. I want to see the year is what I'm interested in, because it is quite old. 1936, right? So it is a very well-known, very well-established sort of set of data. So definitely interesting, and it's kind of that one of those things that everybody's going to do if you're doing data science. So I wanted to show you saw inside of the instructions that you're referencing the Orange libraries. So I thought I'd take a look at it in Orange. So I basically modeled this using Orange. You're not to do that. You're to write it in Python, as the instructions say. But this is, again, in that value add category of maybe adding more to the conversation. So the process starts by loading the file. In this case, I'm using the equivalent of that command that you're asked to use, and I'm actually loading the tab file because this is that's the one that's distributed in the course. And you can see the 5 different columns that are involved, 4 of which are the numeric values, and 1 is a categorical, and I selected it, or actually it came that way, to be the target. Again, if you recall, Orange lets you say which columns are targets, which ones are essentially values. So really pretty compelling stuff to be able to set it up. So to take a look at what it looks like, here's basically the data of the first how many ever we're looking at. So I think there was a total of 150, 50 of each one of the 3. And you can see the various values for each and so on. And this is where it always goes awry. I'm going to try to go off book, right, and try to do a scatter plot and see how that goes. It's probably not going to go well, but oh no, not too bad. This is off of petal length and width, and you can see this one clearly is linearly separatable, right? It's off by itself, where these two not so much. So pretty interesting sort of analysis that you can do rather quickly with tools like this, and that's kind of where things like Orange are really interesting, is they allow you to quickly do some analysis. So the next step is to take it and do data sampling. This is basically where you're doing your train and test settings. In this case, I'm doing 80% of it to be test and 20% or to be train and 20% to be test. The instructions basically said to run it on the entire set. I'm doing something probably a little bit more in line with what we typically do. The next step is to try to learn the rules, and that's what this CN2 rule inducer is. In this case, it told us in the assignment to do an unordered set of rules, so that's what we're doing, unordered. And you can control things like the beam width and so on to kind of control the behavior of the rule creation. Once you've created the rules, you may want to view them. And so here's basically the set of rules that this particular tool on the sample of data that it got came up with, and a means of basically classifying based upon these rules. And you can see that is very human readable. You can tell that the pedal length is less than or equal to 3, and the pedal length and the sample width is greater than 2.9, then it implies that particular type. So basically, pretty easy to understand. And then if basically if none of the others come true, then it's got to be this last one, right? So that shows you the rules. Then you can go through and run some predictions. And so given some various data is what it predicts it to be. And then what we care about the most probably is the confusion matrix, right? So with this, it's doing a reasonably good job. And it's showing you of the ones it predicted, pretty much how well it did. And again, you can see I've wired this up with the sample here is going into the rules. So that's the 80%, and the 20% is coming in here to be used in prediction to come up with our confusion matrix to see how well we did. Now, the challenge with this particular assignment is that that bit in there about cross-validation method and ROC under the curve, ROC curve. So that I had some challenges. So I don't think ROC, well, maybe I'm just not, didn't quite get it. Yeah, maybe it can do it. So I didn't bother to search for that the last time. So interesting. Maybe it does. That was one of the metrics it talked about, and the cross-validation method. So I recall whenever I was doing these, that one was hard to track down. Primarily because it had something to do with the version of Orange. If you go to the latest and greatest version, which is 3 dot something, whenever that method I don't believe is still around. So you may have challenges getting it to work using that particular method. We can go ahead and take a look at, as soon as I find it, that particular assignment, and I'll try to hide the interesting bit. But I do recall that particular method being problematic. So here's a notebook for this particular project. I did have to use the -- use feature resolve for the 2020 resolver. There was a challenge getting it to load otherwise, so you may want to make note of that. That was to do the pip install of Orange. Then here, Orange already knows about, in this case, the IRIS dataset. So that's a reasonable alternative to doing the approach as specified in the assignment. Take a look at the first 10 records. And same basic data that we've seen before. Then you go through and create essentially an unordered learner. I set the beam width to 10. I don't believe that was specified in the assignment. Oh yeah, no, it doesn't. It doesn't say. So that's something that you might want to play with to see if it has an impact or not. But it's not really specified. And the main thing is making sure it is unordered. Create a classifier, run the results, create a learner, and then to use the learner to create a classifier, have the classifier do the results, and then you'd want to be able to print out the list of rules which is, I think, fairly close to those rules. Uh, 3, 2.9, 3. Well, that one's a little different. Could be very much because of the sampling that we're doing inside of here versus we're not doing that in the notebook. But this is where I ran into some challenges with this cross-validation. I think I finally got it to work, but it was, if you have some challenges, that may be why. That may be part of why I had to do that, this resolver thing as well. But don't be surprised if it takes you a little bit. Also, keep in mind that this is just a sketch. This doesn't necessarily, if you were to turn in what I've turned in, or I've shown you here, doesn't necessarily mean that you're going to see. It's not everything that's specified. I'll say it that way. So, but it should give you a good head start and get you going down the path. So the interesting part, again, to kind of wrap this up. It's interesting to utilize Orange's libraries to do the rule induction and determination. That's one of the characteristics of Orange, is that it does allow you to do both interactive, like I've got on the screen, sort of data science work, but also it allows you to use the same components from Python. So pretty interesting stuff. As always, if you have any questions about any of the material that I've went over, do feel free to reach out. That's what I'm here for. Again, the resources that came in pretty handy whenever I was going through this as well. Take a look at some of the links that I had in the notebook. As always, let me know if you have any questions. Let me know if this was beneficial or what you would like to see more of. Stay safe, and we'll speak again on Wednesday.